Lesson 14. Inductance. Section 14.2. Solenoid coil, toroidal coil. This is an inductor called a solenoid coil. A current of I amperes flows in the coil. Then a magnetic field with a strength of H amperes per meter is generated. Its direction follows the right-hand screw rule. The length is L meters, and the radius is R meters. This is a cross-sectional view of the solenoid coil. Next, let's find the inductance of this coil per unit length. The internal inductance of the coil conductor is assumed to be negligible. Two additional assumptions are made. The first is that the length L is sufficiently long so that the fringing effect is negligible. The other assumption is that the radius R is small enough so that the magnetic field strength H inside the solenoid coil is uniform. Ampere's law is applied to the closed path CP as shown in this figure. If there are n turns of coil per unit length, then Ampere's law can be expressed by this equation. The line integral can be decomposed into these four separate line integrals. H2 and H4 are almost zero because they are perpendicular to the magnetic flux in the solenoid coil. H1 is also almost zero because the magnetic flux lines outside the solenoid coil are sparse. Only H3 remains significant. Thus, H3 equals Ni. The magnetic field strength H is assumed to be uniform inside the solenoid coil and is expressed by this equation, where Ay is the unit vector along the y-axis in Cartesian coordinates. The flux linkage of one turn is given by this equation, where S is the cross-sectional area of the solenoid coil, and the ds is a differential area vector. Phi is obtained as shown in this equation. Per unit length, there are n turns, resulting in the flux linkage per unit length of the solenoid coil. Therefore, according to the definition, the self-inductance of the solenoid coil per unit length is derived as shown in this equation. The self-inductance of solenoid coil is approximately the product of lowercase l times uppercase L. The actual inductance is smaller than this approximate value due to the fringing effect and the non-uniformity of H inside the solenoid coil. Exercise 14.2.1. Pause the video and answer the problem. Find H, the flux linkage of one turn phi, and the self-inductance of the torus coil. The answer to exercise 14.2.1. Pause the video, and check the answer. This is the continuation of the answer to exercise 14.2.1. Pause the video and check the answer. Exercise 14.2.2. This is your homework. Pause the video, and answer the problem. Exercise 14.2.3. This is your homework. Pause the video, and answer the problem. The author of this material is Takeshi FURUHASHI, Professor Emeritus, Nagoya University. If you have any questions, send emails to this address.